Hello everyone, my name is Christine May A. Caballo. In this video, I will explain the first come first serve or FCFS CPU scheduling algorithm. FCFS is a non-primitive scheduling algorithm. This means that once a process starts executing on the CPU, it continues running until it finishes. The main idea behind FCFS is very simple. The process that arrives first gets executed first, just like people lining up in a queue. Let's discuss how FCFS works step by step. First, processes enter the ready queue when they arrive in the system. The CPU always selects the process that arrives earliest. Once selected, the process runs until its burst time is fully completed. There is no interruption even if another process arrives while the CPU is busy. Here are some important terms you need to understand. Arrival time. The arrival time is when a process enters the ready queue. The burst time. The amount of CPU time a process needs to complete. Then the waiting time is how long a process waits before execution. The turnaround time is the total time from arrival to completion. Since FCFS is a non-primitive, it does not use time quantum or priority. Now let's look at an example to better understand how first come first serve scheduling works. First, here is our process table. We have three processes, P1, P2, and P3. P1 arrives at time 0 and needs 5 units of CPU time. Process P2 arrives at time 1 with a burst of time of 3. Process P3 arrives at time 2 and needs 2 units. Since FCFS schedules processes based on arrival time, the CPU will execute them in the order they arrive. So P1 arrives first at time 0, which means it will be executed first. Even though P2 and P3 arrive while P1 is running, they must wait because FCFS is non-primitive. Next, P2 arrives at time 1, so it will be executed after 1 finishes. Finally, P3 arrives at time 2 and will run last. Now let's look at the Gantt chart. P1 runs from 0 to time 5. After P1 finishes, P2 runs from the time 5 to time 8. Then P3 runs from time 8 to time 10. Next, we calculate the waiting time for each process. P1 starts immediately when it arrives, so its waiting time is 0. P2 arrives at time 1 but starts at time 5, so it waits 4 units. P3 arrives at time 2 and starts at time 8, so it waits 6 units. Now let's calculate the turnaround time, which is the completion time minus the arrival time. For P1, it is 5 minus 0, which equals 5. For P2, it is 8 minus 1, which equals 7. For P3, it is 10 minus 2, which equals 8. Finally, the average waiting time is the sum of all waiting times divided by the number of processes. That is 0 plus 4 plus 6 divided by 3, which gives us 3.33 units. This example clearly shows how FCFS strictly follows the order of arrival without interrupting any running process. Now let's analyze FCFS. The advantages of FCFS is very simple and easy to understand, easy to implement, fair in terms of arrival order. Now the disadvantages of FCFS is that it can cause the convoy effect where short processes wait behind long ones, poor performance in interactive systems, and high average waiting time in some cases. Now, in which it is best use cases, FCFS is best used in batch processing system environments where tasks arrive in a predictable order, and then lastly, systems where simplicity is more important than speed. To summarize, first come first serve is a non-primitive scheduling algorithm that executes processes strictly in arrival order. While it is easy to implement, it is not always efficient for systems that need fast response times. Compared to algorithms like round robin, FCFS is simpler but less flexible. Thank you for watching.